So now we are moving to the next portion, definite integrals. Exercise 7.8, and the first question is evaluate the following definite integrals as the limit of sum. Definite integral means there will be a lower limit and an upper limit, and we have to substitute these limits after integrating the given function. So here the question is to find the integral, but we have to apply the method of limit of sums. To use this method, what we have to do first is write f of x. The function given is x. Okay, the lower limit is a and upper limit is b. We will find nh. N into h will be equal to b minus a. B minus a means upper limit is b, lower limit is a. So b minus a here is b minus a itself. The next is what we have to do is find f of a. F of x equal to x. So f of a will be equal to a. Then find f of a plus h. F of a plus h will be equal to a plus h. The next value to find is f of a plus 2h. A plus 2h is equal to f of x equal to x. Whatever is there in the bracket, it is there as a function. So here a plus 2h is there inside the bracket. So we have to write as a plus 2h. F of x is x. So f of a plus 2h is a plus 2h, etc. There are many more terms to find, but we will put etc. And the last term we have to find is f of a plus n minus 1 into h. Okay, that will be the same as a plus n minus 1 into h. And how many terms are there? Here it is 1h, 2h, 3h, 4h, etc. n minus 1h. That means from here, till the last term there are n minus 1 terms. And there is one more term. So n minus 1 plus 1. Total, there are n terms. Now we are going to find the integral. Integral a to b x dx equal to, the formula is given by limit h tends to 0, h into f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1 into h. So you have to by heart the formula and keep it in mind. There are n terms inside this bracket. So we are going to apply the values. Limit h tends to 0, h into, what is f of a? F of a is a. So a plus, what is f of a plus h? A plus h plus a plus 2h plus etc. a plus n minus 1 into h. Okay, so this is the first term, this is the second term, this is the third term, and this is the nth term. In all the term, a is there. So a plus a gives you 2a. 2a plus a gives you 3a. 3a plus here again a is there, 4a. Likewise, in all the n terms, a is there. So when a is added 3 times, we are getting 3a. When a is added 5 times, we will be getting 5a. Here there are n terms and all the terms contain a. That means we can write the a terms as limit h tends to 0, h into a plus a plus a plus etc. n times. There are n terms, so a plus a n terms or n times, whatever it is. And balance in the first term, nothing is there. In this term, there is an h. In the next term, there is 2h. In the next term, though we didn't write, we know that it will be 3h plus etc. And the last term is n minus 1 into h. Okay, that is equal to limit h tends to 0. H into a plus a plus a. 3 times when added, we are getting 3a. So we are now, here we are adding n times. So na plus, in this bracket, what is common? H is common. So I am taking it outside. 1 plus 2 plus 3 plus etc. plus n minus 1. This bracket we already know. We have studied in the plus 1 classes sum to n terms of special series. So that is what it is given here. 1 plus 2 plus etc. plus n is given by the formula n into n plus 1 by 2. N into n plus 1 by 2 if it is 1 plus 2 plus etc. plus n. Here we have only 1 plus 2 plus etc. plus n minus 1. So the formula is n into n minus 1 by 2. So we will write the formula limit h tends to 0, h into, the first term remains the same, na plus h into n minus 1 by 2. This is a formula for the bracket 1 plus 2 plus etc. plus n minus 1. Again what we have to do is we have to collect n and h terms together. Why? Because we know the value of nh as b minus a. So collect nh together. Okay, again from the outside bracket, there is an h outside the bracket. So when we distribute or when we open the bracket, first term becomes nha. So we can have an n and h together. To the second term also we have to multiply h. So this h we will multiply with this n minus 1 because already nh is taken together and this n minus 1 is there. So we will multiply this h to this term. So how we will rewrite as the first term, limit h tends to 0. I am just going to open the bracket NHA. The first term is the same, n into h into a. For the second term, actually the term becomes h into hn into n minus 1 by 2. So we have taken nh together and this h we will multiply to this n minus 1. So what we get? nh minus h by 2. Okay, so the term becomes nh into, nh is there and this become nh minus h by 2. Again what to do is, instead of nh we will be giving the value b minus a. So limit h tends to 0. nh is b minus a into a plus b minus a into, again instead of nh we can give b minus a minus h by 2. And the last step to do is apply the limit. Limit is h tends to 0. Wherever h is there you can give the value 0. So what we get? B minus a into a. The first term remains the same as there is no h. In the second term this is the same, b minus a. And what about here? Here when h takes the value 0, b minus a is b minus a itself, isn't it? So b minus a by 2. So that is equal to, what is common here? B minus a is common. And the balance is a plus b minus a by 2. When taking the LCM, what we get? B minus a into, this is 2a plus b minus a. 2a plus b minus a. 2a minus a gives you a. So what we get? A plus b by 2. Now the numerators of the form b minus a into b plus a, which gives you the value b square minus a square by 2. This is the value of integral a to b x dx. Okay.